Okay, this is adding and subtracting rational expressions. This is the first of 3 lessons that are on the more intense side. Okay, the first of 3. We've got adding and subtracting rationals, we've got complex fractions, and then we have rational equations. So be patient with yourself. Be sure that you are working in MyMathLab. Be sure you give yourself enough time to walk away from MyMathLab and come back to it. And also be sure that you are using resources such as SOAR, My Student Hours, Smart Thinking, and the videos. Okay, so don't hesitate to go back and rewatch the videos as you are working inside MyMathLab. Okay, so adding and subtracting rational numbers. And we've talked a little bit about rational expressions are fractions on steroids. So all the stuff where we practice how to add and subtract fractions, we're going to carry that over into adding and subtracting rational expressions. That's what we're doing right here. So the thing that you want to look at is that we are going to have a common denominator. When we are multiplying and dividing rational expressions, we do not have to have a common denominator. Adding and subtracting rational expressions, you must have a common denominator. Okay? You must have a common denominator. Okay. And then when we add or subtract, we keep the denominator the same, and we just add or subtract the numerators. Okay? Numerator is the top number. So here we are adding and subtracting both of these. The key part to this right here is that we already have a common denominator. We already have a common denominator. So here I've got 3y and 3y. So I keep my denominator. Okay, I keep the denominator and I add the numerators. That's what's happening right here. I keep the denominator and I add my numerators. Okay? So my denominator is going to be 3y. 8x plus x. What is 8x plus 1x? 9x. Okay, so I added my numerators. I keep my denominator. Now I can simplify. What goes into 9 and 3? 3. So the 3 in the denominator becomes 1. The 9 in the numerator becomes 3. So my final answer to this is going to be 3x over y. Okay, so that right there is my final answer, 3x over y. Okay, now for the next one that we're going to look at, it is subtraction. I want you to always change subtraction to addition. Okay, so I want you to change your subtraction sign to addition, and then I want you to move the negative to numerator. Sometimes that means you're going to have to distribute. Sometimes when you move the negative to the numerator, you have to distribute. And we will do problems like that. So this is going to become plus, and my 16 becomes negative. Okay? So I changed my subtraction to addition, and I moved the negative to the numerator. So now I've got a denominator that's the same. So I have y minus 2. And then in my numerator, I have 8y minus 16. When I get here, you always ask yourself, can I simplify further? And I can. What can I do in the numerator? Good, I can take an 8 out. Okay, so then I am left with 8 times y minus 2 over y minus 2. My y minus 2's cancel, so what's my final answer here? Positive 8 is my final answer right here. Oops. Okay. So it's important that you remember With adding and subtracting rationals, just like with adding and subtracting fractions, you must have a common denominator. Must have a common denominator. Okay? Okay. Can I go to the next slide? Okay, now we're doing these again. We just have a little bit more complex denominators. These are exactly the same. They already have a common denominator, 2 pi plus 7. So I am going to rewrite this using my common denominator. So I have 2 pi plus 7. And then I've got, as my numerator, 4p minus 3 plus 3p plus 8. Okay? Now I can combine like terms. I have 4p and 3p. What's 4p plus 3p? 7p. Then I have negative 3 and positive 8. You're good. Then I keep my denominator the same. I do not do anything with my denominator. I keep it the same. Okay, and so that, you always pause, like, can I simplify anything further? And I can't, so this is my final answer right here. Okay? Now, for this one, we are subtracting. What do I want you to do with this subtraction sign? Good. I'm going to change it to addition, and where's the negative going to go? With the 6. It's going to go right there, okay? Now, sometimes you have to distribute that negative. And we'll get into more of that later. Okay, just be aware of that. I'm going to go ahead and rewrite this. So in my numerator, I'm going to have 3y minus 6. My denominator is going to stay the same. So I'm going to have y squared plus 3y minus 10. We always pause. We pause right here and we say, can I simplify further? Okay, is there something I need to do to simplify further? Good, this one can be factored. So we do want to factor that. What can I take out of the numerator?
30.
Good, and so then I'm left with 3y minus 6, or 3 times y minus 2. Okay, 3 times y minus 2. Then I factor my denominator. Good, 5 is one of the numbers, and what's the other? Negative 2, excellent. Okay, so then I've got y minus 2 and y plus 5. Okay, and so my final answer to this is going to be 3 over y plus 5. Okay, now, that is reminding us how to add and subtract when I have a common denominator. Okay, once we remember how to add and subtract like fractions, we typically do okay with adding or subtracting rationals with like denominators. What gets a little bit more complicated is when we have to find a common denominator. And to do that, we find what's called the least common denominator. Least common denominator. To add or subtract rational expressions with different denominations, that means your denominators are not the same. That's what that means. You have to change them to equivalent forms that have the same denominator. Common denominator. This involves finding the least common denominator of the two original rational expressions. So now what we're going to do for the next few minutes is we're just going to practice finding the common denominator. Okay, and then we're going to practice finding equivalent fractions. So that's what we're going to do for the next few minutes. Okay, least common denominator. The denominator is the bottom part of your rational. It's the bottom part of your rational. First, step one, factor each denominator completely. The least common denominator, which is your LCD, is the product of all unique factors found, each raised to a power equal to the greatest number of times that the factor appears in any one factor denominator. Okay? So if you've got x squared, and then you've also got x squared is the highest power, the highest exponent, so x squared is going to be part of your common denominator. Okay? So let's do these. Let's just look at these and do these. Okay? 9 and 15. 9 and 15. You are used to doing with numbers the least common multiple. That's what you're used to doing, and that's probably what you did when you were younger. The least common multiple means we've got 9. Okay? So the least common multiple for the multiples of 9 is 9, 18, 27, 36, 45, 54. And they just keep going for as many as I need to go. Okay? I'm just adding 9 to every single one. For 15, I go 15, 30, 45, 60. Now, do I have a common one? 45. Okay? So my least common multiple and my least common denominator for this one are 45. Now, once we start dealing with variables, this method does not work as well. This method will only work for numbers. It doesn't work when we are talking about variables. So what we have to do is we have to factor the denominators. Okay? So my two denominators are 9 and 15. So we are going to break that down into primes. That means we're going to factor it. So what is 9 factor to? 3 and? Good. 3 times 3 is 9. What is 15 factor to? Good. So 3 times 5. So my least common denominator is going to account for all of these. Okay? So the first thing that I'm going to do is I'm going to highlight what's common. Okay? Do you see how I've got a 3 and a 3 there? So because it's common, I only write it down once. So you write down what's common once. Okay? So I'm going to put this right here. This is what's common to both. Then what I have to do is I have to write down everything else. Okay, so this right here is what's left over. Okay? Now, 3 times 3 is 9. 9 times 5 is 45. So we have found the same answer using a different method. And this is the method that we're going to have to use. When you were doing fractions, when you were younger, you probably used the least common multiple method. And we can't do that when we add our variables in. So we want to use the factoring method. Okay? So that's the first one that we're going to do. So now let's do the next one. So I'm going to take my 6x cubed, and I am going to write down all the factors of 6x cubed. What does 6 break down to? 2 and 3. Okay, and then just for visualization, I'm going to write down each of the x's separately. So x to the third is x times x times x. Okay, now I've got 8x to the fifth. And I need to break 8 all the way down. Okay? All the way down. What does 8 break down to? Okay, so 2 times 4. 4 can be broken down further. Correct. You've got to break it all the way down. That's where our factor tree comes in. Okay, so you do your 8. You break it down to 4 and 2. 2 is prime, so we go ahead and circle that. But 4 breaks down to 2 and 2. So we've got 2 times 2 times 2. So that's what we want to write down. 2 times 2 times 2. And then I've got x to the 5th. Okay? And you will get to the point where you don't have to write all the x's down. But right now, I want you to write them all down. Okay? Now, my LCD, first thing I'm going to write down is everything that's common. Okay? I'm going to write down everything that's common. So I've got a 2 and a 2 that's common. Then I've got x, x, and x that's common. How do I write this right here? How do I write x times x times x? Okay, actually, I just want to write it down, just x times x times x. X to the 3rd. Good. Okay, so I've got 2 times 2 that's common. Okay, and then I've got x to the 3rd that's common. Okay, so what I've done right here, this right here is common to both. It's common to both. Now what I've got to do is I've got to write down all the leftover. So I've got 3 times 2 times 2, and then x times x. That's everything that's left over. Okay? So I've got, okay. So then I've got 3 times 2 times 2 times x to the what? Squared. So this part is what's left over. All of it is your LCD. All of it is your LCD. So what I have to do to get my LCD then is I'm going to multiply 2 times 2 times 3 times 2 times 2. Oh, I wrote 2's down. Okay, let's go back. I wrote too many 2's down. Okay. So we're going to start right here. My LCD right here. Okay. Do you see how this 2 right here is common to both? I only write that down once because it's common to both. Okay, so I'm going to write the 2 down because it's common to both. And then I have x to the 3rd that's common to both. So this right here is common to both. Okay? Now, the purple is what I write down next. So I've got 3 times 2 times 2, and then I have x times x. That is not common to both. This is what's left over. You only write down what's common to both one time. Okay, so I made a mistake there, so you want to be sure you go back and you fix that mistake that I made. Now, my LCD, I multiply all of those together. So I'm going to say 2 times 3 times 2 times 2. So what is 2 times 3 times 2 times 2? Good, 24. Okay, so my LCD is going to be 24. Then I've got x cubed times x times x. What's that? X to the 5th. Okay, now let's talk about this for a minute. Okay, my least common multiple. So if I had done this right here with my numbers, 6 and 8, if I had done my least common multiple, I would have had 6, 12, 18, 24, and 30. And then 8 is going to be 8, 16, and 24, and 32. Okay, so here is my least common multiple. Do you see how I got the same thing right here? Okay, so you can do the numbers either way. What you have to be careful of is your variables. Now I've got x to the 3rd and I've got x to the 5th. What's the highest exponent there? X to the what? The highest exponent. 5th, okay? And that's part of my LCD right there. Okay? Okay. This is going to be most helpful for you as you move forward. Breaking it down like this, because we're going to have to start factoring trinomials. And once we do that, you'll want to have it broken down. Yeah, that's a good question. Okay, now let's do another one. We are finding the LCD. So what I want you to do right now, we're focusing on the denominators. The numerators don't matter. We're focusing on the denominator. I want you to factor 6y and 4y plus 12. We are only finding the LCD. We're only finding the LCD. Okay? So factor 6y, and then you're going to factor 4y plus 12. Okay? What does 6y break down to? Good. So I've got 3 times 2, and then what's my variable? Good. Okay. What can I factor out of 4y plus 12? So I've got 4, and then I've got y plus 3. Now, this is not prime. 2 times 2. Okay, so this actually needs to break down to 2 times 2 times y plus 3. Okay, what is common to both? That's what I'm going to write down first. What is common to both? Okay, there's a 2 common to both and another 2 common to both. Is that it? That is it. Okay, so my 2 is the only thing that's common to both. And I write that down one time. Okay, because it's common to both. Now I'm going to write down everything else. So I've got a 3 and a y, another 2 and a y plus 3. Okay? So I've got 2 times 3 times y times another 2 and then y plus 3. Okay. Now, what I would do is I would multiply these together, but then leave this as a factor. So multiply 2 times 3 times 2. Good. And then I've got my y. And I've got y plus 3. So that is my LCD right there. Okay. Now we're going to look at trinomials. Now we're going to look at trinomials, and I actually think finding the LCD when our denominator is a trinomial is easier. Okay? So what I want you to do right now is I want you to factor each one of these, and I'm going to give you 1 minute to factor both of those. Okay, so hopefully you got both of these factored. X squared plus 4x plus 3. Product is 3. My sum is 4. So that's x plus 3, x plus 1. X squared plus 10x plus 21. My product is 21. My sum is 10. So that's x plus 7, x plus 3. So first thing I do for my LCD is I write down what's common to both. And what's common to both, good. So I only write that down once. I only write down x plus 3 once because it's common to both. Then what's left over? Good. X plus 1 and x plus 7. And it doesn't matter what order you write those down in. Okay, so that is going to be my LCD. Okay? That's my LCD. One more LCD. One more LCD. Two more LCDs. Then we're going to start adding unlike denominators, okay? You're going to focus on factoring the denominator. So I'm going to give you 1 minute to factor that denominator. 1 minute. The second one is a perfect square trinomial. The first one is difference of perfect squares, so make sure you factor those completely. Okay, 5x squared minus 5. You pull a 5 out, and you're left with x squared minus 1. X squared minus 1 goes further. X plus 1, x minus 1. Okay, so make sure you got that right there. Okay? Then our second one, x squared minus 2x plus 1, that is a perfect square trinomial. It's okay if you don't recognize it as a perfect square trinomial. That's fine. Our product is 1. Our sum is -2. So -1 times -1 gives me 1. -1 plus -1 gives me 2. I would encourage you to write it out like this. Don't try to write it as x minus 1 squared because that could confuse you. First thing I'm going to do, I'm going to highlight what's common. So I have x minus 1 and x minus 1. That is common to both. So I write that down one time. Now I'm going to write down everything else. Okay? So I'm going to do times 5 times x minus 1. So my LCD for this is 5 times x minus 1, x minus 1. And the thing that I want you to realize here, because there is 2 x minus 1s right here, you've got to have 2 in the LCD. You've got to account for both of them as part of the LCD. Where is x plus 1? Oh, I highlighted the wrong thing earlier. Okay. Okay, no, I just need to write down x plus 1. Okay, so I've got x minus 1, x plus 1. There we go. X minus 1 times x minus 1 times x plus 1. Okay, there we go. I think I'm ready for spring break 2. I'm not going anywhere. I'm at home for a whole week by myself, and my husband and children have to work. Okay. One more. And this is one that sometimes is a challenge. Okay. Here our denominators are x minus 3 and 3 minus x. X minus 3 and 3 minus x. Now, the number one thing that students do right here is they say that their LCD is x minus 3 and 3 minus x. That's what they say. That's what they say that their LCD is. And that's okay. You're going to get to the same answer, but you're eventually going to have to factor again and simplify further. So you can make this easier on yourself if you deal with this early. We deal with this early. Now, what I want you to do for this one is you've got your x minus 3. That does not change. You can't factor it any less. So you're just going to have x minus 3 as a factor. But for 3 minus x, I want you to factor out a negative 1. When I factor out a negative 1, I'm left with negative 3 plus x. Negative 1 times negative 3 is positive 3. Negative 1 times x is negative x. So that can be a rewrite as x minus 3. So then, x minus 3 and x minus 3 are common. Okay, so my LCD is going to be x minus 3. And the reason for that, let me show you the reason for that. So I've got 1 over x minus 3. And then I've got this right here, 3 minus x, is the same thing as negative 1 times x minus 3. Then I've got my 2 up here. Am I allowed to take this negative and move it to the top? I am. Okay? So instead of negative 1 times x minus 3 being my common denominator, what I'm going to do is I'm going to make this negative 1 go to my numerator. And as long as I account for my negative, I'm good. It makes the problem significantly more straightforward when you do that. So this is how I would do my rewrite when I start adding and subtracting these. And that's what we're going to do now. Okay, so we've talked about how to find your LCDs. Actually, we're going to write equivalent fractions first because this is important too. Okay, equivalent fractions. So, writing equivalent fractions. You are used to writing equivalent fractions with, and we talked about this on Thursday in class. Okay, if I tell you that I've got 1/2, but my common denominator is 10, I ask myself, 2 times what gives me 10? 2 times what gives me 10? 5. So I multiplied the 2 times 5 to give me 10. So what do I have to do with the numerator? Multiply by 5. So 1/2 and 5/10 is exactly the same. So I'm going to have to do that now when I start adding and subtracting unlike denominators. So I'm going to have to do that now. So let's do a couple of these before we really get into adding and subtracting unlike denominators. Okay, here's the first one that I'm going to do. Here's the first one. So I've got 3 over 9y to the 5th. 3 over 9y to the 5th. Now, what we're looking at right now is that my LCD is going to be 72y to the 9th. Okay, so that's my LCD. And they gave us that. We're not looking at two different fractions. They told us that this is what we're going to do. So my LCD is 72y to the 9th. So what I'm going to do is I am going to look at what is it that this fraction is missing. Okay, so here's 9. What do I need to do to 9 to get to 72? It's going to be 8. I have to say 9 times 8. Okay, so if I multiply this times 8, what do I have to do to my numerator? Multiply by 8. Okay, now, y to the 5th, what do I need to multiply y to the 5th by to get y to the 9th? Good, y to the 4th. And if I multiply the bottom times y to the 4th, what do I multiply the top by? Excellent. Okay, so 8 times 3 times y to the 4th is going to be my new numerator. Okay? So that is finding equivalent fractions. And we have to find equivalent fractions before we can add or subtract the numerators. Okay? So that's what we're going to focus on. Now, let's do one more, and then I promise we're going to do addition and subtraction of unlike denominators. One more of these. Okay. Write an equivalent rational expression with the given denominator. The denominator that we need is x plus 5, x minus 5, x minus 3. That's the denominator that we need. The denominator that we have is x squared minus 25. So I'm going to rewrite this. What is x squared minus 25 factor to? Good. It's difference of perfect squares. So x plus 5, x minus 5. Okay? Now, what is my denominator missing? X minus 3. Okay? That's what I don't have. I don't have this x minus 3. So if I multiply my denominator times x minus 3, what do I have to do in my numerator? Same thing. Okay? So my equivalent fraction here is going to be 3 times x minus 3 over x minus 3 times x plus 5 times x minus 5. Now, you will likely have to multiply this out so that we can add the numerators. It's okay, because right now we're just trying to find equivalent fractions. But when we start doing the multiplication, then you'll have to multiply all that out. Okay, is everybody ready? We got this, right? We got it. Okay, here we go. Can I move off this page? Here we go. Adding or subtracting rational expressions with unlike denominators. The first thing that we have to do is find the LCD of all the rational expressions. The LCD focuses on the denominator. We are not worried about the numerator yet. We are focusing on the denominator. That's what we're doing right here. Focus on denominator. Okay, focus on denominator. Step 2, rewrite each rational expression as an equivalent expression whose denominator is the LCD found in step 1. So our second step is to make sure every rational expression includes all parts of the LCD. So anything that's missing, we've got to multiply the numerator and the denominator by that. The numerator and the denominator. Okay? Step 3, add or subtract the numerators and write the sum or difference over the common denominator. And step 4 is to simplify. Okay? Simplify. So first thing, we're focusing on denominators. The second, we are focusing on equivalent expressions. Okay? Next step, we focus on the numerator. And the last step, we simplify. This is one of those situations. You want to have this close to you as you are working through these problems. You want to have them close to you. Okay? We ready? Okay. So, first thing that we want to do is we want to find our common denominator. We want to find our common denominator. So I am going to focus on the denominators. So I have 7a and I have 6a. Now 7a doesn't, it's 7's prime and we just have a. 6 will break down. What does it break down to? 2 and 3. And then I have an a. What is common to both of these? A. So I am going to write the a down one time because it's common to both of those. Okay, so I'm going to have my a. What's left over? 7, 2, and 3. So I have to include all of those because everything has to be represented. Everything over there has to be represented. Okay? So now my LCD is 7 times 2 times 3 times a. Now, some students will go ahead and multiply that out, and that's okay if you go ahead and multiply it out and you get 21. That's okay. Okay? I like to wait. No, it's not 21. How did I mess up this time? 42. Oh, no, it is 42. I know what's happening. Okay, so 2 times 3 times 7 times a. Now, that does equal 42a. It does, okay? But I don't want us to think about that yet. That 42a is something that we'll do in a second. I like to leave it like this for now. So now I am going to rewrite 15 over 7a. Now I want to know what's missing. So I've got my 7 and I've got my a. So I've got my 7 and I've got my a. What's missing? 2 and 3. So if I multiply the denominator times 2 times 3, what do I have to do to the numerator? Same thing. Okay, that's why I like to leave it broken down. We'll turn it into 42a in a second, but I like to keep it broken down at first. Then I'm going to add 8 over, and I'm going to go ahead and break that 6a down to 2 times 3 times a. Okay, and we know that 6a and 2 times 3 times a is the same thing. So now I've got a 2, I've got a 3, and I've got an a. What's missing? Good. So I write the 7 down in the denominator. So what do I have to do to the numerator? Times 7. Now in this step, I can write it down as 42a. Keeping it broken down helps me identify what's missing. And it helps me find the equivalent fractions. Okay? That's what happens there. So I've got 42a. 15 times 2 times 3. What's 15 times 2 times 3? Okay. It's 90. What's 8 times 7? 56. Okay. And 90 plus 56 is going to be 146. Thank you. Can that be simplified further? It can. What goes into both of these? 2. So 42 becomes 21, 146, is that 73? Somebody check me. 146? Good, okay. So then my final answer here is 73 over 21a. And we have to do that for every single problem. You've got to break it down that way. Got to break it down that way. Okay? Let's try the next one. We ready? Okay. We're dealing with numbers here, so it's not too bad. So I have 5. Can 5 break down at all? Whew, excuse me. It's the Holland. Okay, what does 15 break down to? 3 and 5. Okay.
Do we do the add and put the negative?
Yes, we will do that. Yes, absolutely. Okay. So my LCD, what's common to both? Good. Okay, the 5 is common to both, so I write that down once. What's left over? 3. And I know that my LCD is going to be 15, but keep it as 5 times 3. Now, I want to doctor this. I want to do a rewrite right here. What do I want you to do with that negative? Good. I want it to become positive or addition. And where do I move my negative? Good. Move it to the numerator. So now I have y over 5 plus negative 3y over 3 times 5. Okay? Now, for this fraction right here, what's missing? Good. So I've got my 5, but I don't have the 3, so I'm going to multiply this times 3. If I multiply the bottom times 3, I've got to multiply the top times 3. Nothing's missing here. It's just 3 times 5. So now I can do the rewrite. I have 3y minus 3y over 15. What's 3y minus 3y? 0. Is 0 over 15 legit? I've got some no's and I've got some yeses.
0.
It is. You're correct. It's 0. What is not okay? 0 on the bottom. 0 on the top is totally fine. 0 on the bottom is not. Okay. You guys are getting the hang of this. Okay. Okay, let's do the next one. We got some factoring and we've got some subtraction to deal with.
Okay, one more question.
Yes, of course.
What would be our final answer? Is the LCD or is it zero?
Zero is good. That's a good question. So the question is, what is my final answer? When I am adding and subtracting, my final answer is 0. Okay? Earlier, we were trying to identify the LCD, and that's when your LCD would have been your final answer. You're not going to have many of those. Most of these are going to be adding and subtracting. Okay? Good question. Okay. Now, I want to focus on those denominators. So the first thing I'm going to do is take the x squared minus 9. And that's a difference of perfect squares. So I'm going to factor that to x plus 3, x minus 3. Okay, and what's my second denominator? Good, I can't break that down at all, so it just stays x plus 3. Okay, I want to deal with this negative, and where am I going to move it? Good, so this right here is going to become plus, and that 5 is going to become negative. Now hold on to that negative 5, because we're going to have to distribute that in a minute, and I want us to see why. So I've got 10x over x plus 3, x minus 3, plus negative 5 over x plus 3. So everything here is already accounted for. I didn't write down my LCD. So my LCD, I've got x plus 3 that's common, and then x minus 3 that's left over. So my LCD is x plus 3 times x minus 3. So here, I've already accounted for both in my LCD, so I don't have to do anything to that fraction. I don't have to do anything there. Okay, but what's missing here? Good, x minus 3. So I'm going to multiply the denominator times x minus 3. And if I do that, what do I have to do to the numerator? Good. And now I've got to distribute. So that's something you want to watch. So when you multiply in the numerator by a binomial, you are going to have to distribute. Okay? So I'm going to leave my denominator factored. I'm going to leave it factored. So I've got x plus 3, x minus 3. I keep my 10x, but here, what do I want to do? Good. Don't forget to distribute that negative 5. Negative 5 times x is negative 5. Negative 5 times negative 3 is positive 15. Okay? So now I combine like terms. Is that going to be 5x plus 15? I'm not done. There's something else I can do here. What can I do? I can. So at this step, don't assume you're done. Ask yourself, can I simplify further? Can I simplify further? Okay, the answer to that is yes. I'm going to pull out a 5, and I'm left with x plus 3 over x plus 3 times x minus 3. This is why we don't multiply the denominator out yet. So my final answer is going to be 5 over x minus 3. Okay? You want to give yourself time. You've got to give yourself time to work on these. Got to give yourself time. Okay. Can I go to the next one? Okay. This one is actually significantly more simple than it looks. So what you don't want to do is get too large of a common denominator, because the least common denominator on this is not bad. It's not bad. Now, first thing is we're going to look at these two denominators. I've got 2x minus 6, and then I've got 6 minus 2x. Okay, I hope that when you see that, you're like, oh, those are similar. Maybe I need to think about pulling out a negative number. Now, in my top one, 2x minus 6, that can be factored. What can that be factored? What can I pull out? 2. And then I'm left with x minus 3. Now, instead of taking a 2 out of this one, I want you to take a negative 2 out. Okay? So this is going to be negative 2, and that'll give me negative 3 plus x. And when I rewrite that, what do I get? X plus 3.
No.
It's going to be negative 2 times x minus 3. Did I say plus? I did. I said plus. Okay, that's good. We're ready for spring break. That's what it is. Okay, now, I want you to look at some of the rewrites that we're going to do here. This minus right here, I want to change it to a plus, and I'm going to move that to the top. Okay, so now I've got 5, and instead of 2x minus 6, I'm going to write 2 times x minus 3. That's plus negative 3 over negative 2 times x minus 3.
Wait, I got one.
Yes?
Okay, so I went on and took out the negative 1 from the 6 minus 2.
Okay.
Do I need to go with that or?
It's always a good idea to break it down as far as you can. In this situation, if you had made your common denominator 2x minus 6, you would have been fine. But in general, it's always good to break it down as far as you can. Okay, now, I want you to look at that negative 3 over negative 2. What's negative 3 over negative 2?
No, 3 over 2.
Yeah, it's positive. Okay, negative 3 over negative 2 becomes positive 3 over 2. So I can go ahead and do that. Negative over negative makes a positive. Now I have common denominator, right? So when I have a common denominator, all I have to do is what? Yeah, add the numerators. I've already got a common denominator. So I've got 8 over 2 times x minus 3. Okay? Is there anything else I can do here? Good.
So we don't distribute?
In the denominator? You always want to distribute if you need to distribute in the numerator. You can distribute in the denominator, but I want you to wait until the very end. Because what happened here with this one? What could I do? Do you see how I was able to cancel that 2 out? So you don't want to distribute in the denominator until the very, very end. Okay? That's a good question. But if it's in the numerator, yes, you're going to distribute. And we're definitely going to have one on the next one where we do distribute. Okay, so my final answer to this is going to be 4 over x minus 3. Give yourself time on problems like this. Okay, give yourself time on problems like this because this is a problem that students typically struggle with. So just rework them, give yourself time, come back to it, try it again. Do that kind of thing, okay? Okay. Now, let's go to the next one. Okay, we are subtracting a whole number. What is that 3 over 1? The denominator of that minus 3 is positive 1. Okay, so the first thing that I'm going to do is I am actually going to rewrite this. So I'm going to have 7 over 2x minus 3 plus negative 3 over 1. Okay? Can I break 2x minus 3 down at all? Can't. There's nothing I can factor out. There's nothing I can do. Okay, what about 1? Can I break it down? No. So what's my LCD here, guys? That's exactly right. My LCD is 2x minus 3. If you wanted to write it as 2x minus 3 times 1, you could, but you don't have to. So when I look at this one right here, does it already have everything? It does. What about this one? No. So I'm going to put 2x minus 3 in the denominator. And the numerator. Good. And if I do it in the denominator, I have to do it in the numerator. And what am I going to have to do with that negative 3? I'm going to have to distribute that negative 3. Okay? So now I can rewrite it as a common denominator. Okay? I have 7, negative 3 times 2x is going to be minus 6x. Negative 3 times negative 3 is going to be positive 9. So my answer to this is going to be 16 minus 6x over 2x minus 3. Now, it's always a good idea to pause right there and see if you can factor that to where it will help. You could take a 2 out of the numerator, but it doesn't get me anywhere. Okay, so just pause and see if factoring gets you anywhere. Say that again. It can factor. You could take a 2 out, and so then you would be left with 8 minus 3x, but then I have 2x minus 3. You cannot cancel those two. Don't cancel those, because this has to stay as a unit right there. Okay? But it's good thinking. You are thinking correctly. Okay, last one. Last one. Okay. First thing that we're going to do is we are going to factor both of these. That's how we find our LCD. We're going to factor both of these. So I have x squared minus x minus 6. Okay. Our product is negative, so I'm going to have one positive and one negative. X minus 3, x plus 2. Yes, that's what that factors to. Then I've got x squared plus 5x plus 6. Now you definitely want to factor this because you don't want to be dealing with two large trinomials. That's your LCD, because we have common factors here. So here I've got this factors to x plus 2 and x plus 3. Okay, so for my LCD here, I have an x plus 2 that's common, so I'm going to write that down once. Okay, and then what's left over? Good. Okay, that's what's left over. X plus 2, or x minus 3 and x plus 3. Now, I'm going to rewrite this. So I'm going to have 4 in the numerator. And then I've got x minus 3, x plus 2. All I did right there is I rewrote the denominator in factored form. That's all I did. Okay, and then I've got x plus 2, x plus 3. So now what you do is you look at this and you look at your LCD. What's missing? I've got x minus 3 and x plus 2. What's missing? X plus 3. And if I multiply the denominator by it, I've got to do the numerator. Okay? Now for the next one, what's missing? And if I multiply the denominator by it, I've got to do the numerator. Okay? Now I've got a denominator, and I'm going to keep that factored until the end. X minus 3, x plus 2, x plus 3. Okay, what do I have to do with that 4? Okay, so I have 4x plus 12. Got to distribute my x, so then I've got x squared minus 3x. Okay, I've got one more step. I'm going to leave my denominator. Okay, x squared. Then I've got 4x minus 3x. What is that? 1x, good. And then I've got plus 12. Okay, now, you always want to pause here and say, can that be simplified further? So that is something that you want to do. You want to say, can that be simplified further? X squared plus 1x plus 12 cannot be simplified further. It is prime, okay? If the 12 was negative, it could be simplified, but the 12 is not negative, so it is prime, okay? Be patient with yourself on these. Work through them, okay? Go back to them. Be patient with yourself.